Are you ready, sir?
Yes, sir. Ready.
Okay, start, sir.
Welcome back to our YouTube channel TREIS. So, previous class yesterday we have discussed that some of the electrochemistry topic. So, some topics we have discussed in that. First, we have discussed about the various types of cells present. Just we have discussed in previous class about the just introduction about the electrochemistry. Today's class we will discuss about the various types of cells as well as EMF of the cell. Okay, right. So what is the various types of cell? Actually, two types of cells are present. One is voltaic cell, galvanic cell, and second one is electrolytic cell. So this galvanic cell, so this one voltaic cell or galvanic cell is also called as electrochemical cell, and second one is electrolytic cell. So this picture indicates the electrochemical cell or galvanic cell. So what is happening in this? The chemical energy is converting into the electrical energy. Okay, so this is a spontaneous reaction. So by spontaneously, the chemical energy is converting into electrical energy. So what is a spontaneous reaction? In general example, so the water flows from high altitude to lower altitude. That is one of the example for the spontaneous. So that whatever the process is happening spontaneously without any external force, the water will be falls down from a up hills. Okay. So is there any force is required to water from high altitude to no altitude, low altitude? There is need not require any force. So okay, water can flow from high altitude to low altitude without any external flow force. That's why that is called as spontaneous reaction. So if water is in the ground, okay, so then is it require any energy to high altitude? There is a tank is there, a ground in water, groundwater is there. Is there any extra, that means any external energy is required to pump that water or not? Yes, exactly, some external force is required so to pump the water from ground state to what is that one to whatever the tank. So at that what is happening, some external force is required. So that process is called as non-spontaneous reaction. Okay, like that. So your voltaic cell or electrochemical cell is a example for the what is that one, electrochemical cell. So in this what is happening, chemical energy is converting into electrical energy. So these two are the electrical chemical energy, chemical reactions taking place here bulb is. So this is example for the electrochemical cell. So this one electrolytic cell. So in this what is happening, conversion of the electrical energy to chemical energy. So this is example for the electrolytic cell. Yeah, so this is regarding about the electrochemical cell. And before going about the discussion about the electrochemistry, some common terms are there in the electrochemical cell. So what are the terms are electrolytic or electrochemical cell? Some common terms are there. What are the terms we will discuss now? So first one, electrode. See this picture. Yeah. So this one also, this one, all this. So see this one. So here zinc this one and copper this one. These are the electrodes. So what is electrode? Electrode definition means conduct electricity between the cell and surroundings especially. So that is electrode. Okay. It is a conductor that helps in the establishing the electrical contact with a non-metallic part of the circuit. Okay. What it helps the, so it is a conductor. Okay. It helps in the establishing the electrical conductance. So this is a one conductor. It flows, so it can flow some electricity to pass through them. So here non-electrolytes are there. Here one solution is there, so it does not have the electricity. So how we have to flow the electricity from the electrode? Okay, this is an electrode and this is non-electrolytic solution. How it will be current will be flow here, some ions are there. So this is called as electrolyte. Here this one, if I take this is an electrode, for example zinc one, zinc, so we can take as a, so corresponding electrolytic solution. If I take here zinc is a electrode and zinc sulfate is a electrolytic solution. Okay, so in electrolytic solution what are present? Ions are present. So because of the ions, electricity will be passed by one ion to other ions. Okay, yeah, zinc 2 plus as well as SO4 minus 2. If water is present, H plus ions along with the Zn and SO4 minus 2, H plus ions, OH minus also present. All these are what are ions. Okay, this is non-electrolytic solution. This is a electrode. So simply this is a electrolytic solution. This one and this one. And this rod is zinc rod is a electrode. And here also this one is copper rod. It is also one electrode. Okay, what is electrode? It is a conductor that helps in the establishing the electrical contact with a non-metallic part of the circuit. This is a non-metallic part, so it helps in the establishing the electrical contact. So that is electrodes. Okay, yeah. So this is electrolytic solution, this is electrode. Yeah, I'm taking two different electrodes here. I'm taking here, representing here zinc to the left side, and here right side you see different color is there. This is copper, this is another electrode. Okay, two different electrodes I am using. Yeah, so that's why I am indicating here two different electrodes. What are two? One is anode and another one is cathode. Okay, these two are the electrodes. Yeah, see this one, this is zinc electrode. So this is copper electrode. Here zinc act as a anode. Okay. So two electrodes are there. One is anode and another one is cathode. What is anode? So it is a electrode from which a current enters into polarized electrical device. Okay. What is this one? It is an electrode. A current here. I will explain how it will be enters into polarized electrical device. I will explain. First you learn it is an electrode, it is an anode. From this current will be enters into non here electrolytic solution. Okay, electrical polarized electrical solution is there here, zinc sulfate. From this one to the zinc sulfate electricity will be enters into this one. Okay, so what will be happen? Zinc gives zinc 2 plus 2 electron like that. So electricity will be so enters into this one. So only electricity will be enters from the anode to the electrolytic solution, but electrons will be flow like this. Okay, that is different. Electron flow is different from the electricity production. Okay, right, electricity. See this one. And one more thing here, salt bridge. Salt bridge, what is the use of the salt bridge? This one, invert U shape. You see this one, this is a invert U shape like this. So this is a salt bridge. So what is the use of the salt bridge? It is for the electrical neutrality. If suppose here more electricity, here 10 electron volts is there, here for example 8 electron volts is there. So why? Because here copper sulfate solution, copper, and we are taking the here copper electrode. So that's why we have to choose the corresponding electrolytic solution. I am choosing the copper sulfate electrolytic solution. So that's why maybe some different electricity is there. Then from the to do the electrical neutrality, we use the salt bridge. This one KNO3 potassium nitrate is a used for the salt bridge. Okay, we are connecting anode cathode to the battery. So these are the some of the common terms used in the electrochemical cells or electrolytic cells, electrodes and electrolytes and salt bridge. Okay, I hope it is clear to everyone. Yeah, so we will proceed to next step. Yeah, so this one, what we are saying, generally we take anode to the left side. We will discuss here anode, zinc as a anode. Okay, that is taking here left side. This is anode. So maybe taken not only zinc, copper, silver, anything we will take here. Zinc, generally we will take the anode to the left side, this one, and cathode to the right side. Okay, electron flow will be takes place like this. So electron flow anode to the cathode. Why? Because at the anode oxidation will be takes place. What is oxidation? Yeah, so oxidation is a process. So in that process loss of electrons will be takes place. For example here A, I am taking here A gives A plus electron. That is called as oxidation process. Oxidation is loss of electron and increase in the oxidation state. I am taking A gives A plus. That means here zero oxidation state plus 1. So increase in oxidation state or lose of electron. A gives A plus 1 plus electron. That lose of electron is called as oxidation. So whatever the loose electrons flow like this. And one more term is here. What is that one? Reduction. So it is a redox reaction. What is redox reaction? In a chemical reaction, both reactions, whatever the oxidation as well as reductions, both happen. That is called as redox reaction. Redox in name also it is itself it is there. Redox reduction as well as oxidation happens in a same chemical reaction, that is called as redox reaction. Okay, yeah. So first one oxidation completed, next reduction. What is reduction? So here loss of electrons means, here reduction means gain of electron. For example, A gives A minus plus electron. Here A is gaining one electron. That process is called as reduction. Okay, yeah, I hope it is clear. So decrease in oxidation state also reduction, or simply gaining of electron. A gives A minus, A plus one electron gives A minus, A gaining one electron. Okay, yeah, gaining of electron is called as reduction process. Here losing of electron is called as a oxidation process. So meanwhile both reactions are happening in this cell, that's why this is a redox cell. Okay, yeah, this is anode left side, this is cathode. Okay, already we discussed what is anode. So in this from the electrode, electricity will be enters into, what is that one, polarized electrical device. Okay, current will be enters. So this is a anode and this is cathode. Yeah, see this one. So this is one of the example for the electrochemical reaction. So what is this one? The cell is constructed with the zinc copper. So this is one of the example. So it is also called as voltaic cell, galvanic cell. Okay, yeah, galvanic cell. So zinc as well as copper. We are chosen zinc electrode, copper electrode, right? So this is one of the electrolytic setup. So electrochemical setup. So in this left side, what we are taking. So this half cell. So overall cell means complete cell reaction. We discussed already in this slide. Okay. Yeah. So this one, complete cell reaction is a redox reaction. Half cell means oxidation process. Another half cell means reduction process. So combining these two processes, what will be happen? Complete cell reaction. Okay. Meanwhile, two processes will be happen. One is oxidation process and second one is reduction process. Now we are taking the one voltaic cell. What is galvanic cell? So in this cell construction, you observe whatever we are discussing discussed at the moment, all are present here. See this one. Yeah, so this is electrode. So this is salt bridge electrolytic solution. See, yeah, see this one. This is a one container. In this zinc rod is dipped, corresponding electrolytic solution. What we are taking here, zinc rod is taking. Okay, yeah, so it is. So in this, what is the corresponding solution we are taking? Zinc sulfate. Okay, so zinc sulfate means zinc. So zinc sulfate is a one of the corresponding solution to the zinc electrode. It is electrode. It is, we are taking as a anode. Generally anode having the negative charge. Okay, right. So zinc is a electrode. So here copper is a cathode electrode. Okay, this is cathode, this is anode. So corresponding solution means copper sulfate we are taking. So copper sulfate is a electrolytic solution and copper is a cathode, and zinc sulfate is a electrolytic solution and zinc is anode. So what will be happen? So this is a salt bridge for the electrical neutral. Okay. So now what is happening? So the process is in this half cell, left side half cell means this one. So in this zinc rod losing the electron while keeping in the zinc sulfate solution by passing the electricity. What is happening here? So zinc is undergoing the reduction oxidation. Zinc gives zinc 2 plus 2 electrons. So this is oxidation half cell. Left one is oxidation half cell. So right, so whatever the electrons will be goes from this, your electron symbol is here, you see this one, this is the electron symbol. So whatever the electrons will be come here, then so electron released in the electrolytic solutions, zinc 2 plus 2 electron, that electron flow indicated here. So to see this one, this is electron flow here, 2 electrons, electron flow. Yeah, so see right one, right side of the electro cell. So in this cell, what is happening? Copper sulfate is present. So copper 2 plus ions are present in the copper sulfate solution. In this copper sulfate solution, copper 2 plus SO4 minus 2 ions are present. So whatever the copper is depositing on the copper rod. So what is happening? The reduction process is happening. Whatever the 2 electrons evolved in the zinc sulfate solution, zinc rod by the zinc rod is gaining by the copper sulfate solution. Okay, here copper sulfate is solution. In the copper sulfate solution, copper 2 ions are present. Whatever the copper 2 ions will be, accept the 2 electrons from the this one anode. Okay, so this flow, whatever the 2 electrons, okay, when zinc rod dipped in the dissolved in the zinc, okay, dipped in the zinc sulfate solution, 2 electrons is evolving. These 2 electrons will be accepted by the copper 2 plus ions. So copper 2 plus ions accepting the 2 electrons, right? So these 2 electrons are, so then what will be happening? It is converting into copper. So copper 2 plus 2 electrons gives copper. This is the reduction half cell. Right one is reduction half cell. Here left one is oxidation half cell. We are discussing already. Redox reaction will be takes place. So overall reaction is oxidation half cell plus reduction half cell. Here two electrons get cancelled. Then write the left side terms and right side term. Here zinc is right side, so left side. So zinc plus copper 2 plus. Then what will be happen after arrow? Zinc 2 plus copper. Overall reaction is, you have to observe, overall cell reaction is zinc is converting into zinc 2 plus and copper 2 plus is converting into copper. Okay, yeah. So the process, zinc is converting to zinc 2 plus, the oxidation process, and copper 2 plus is converting into copper, that is reduction process. So this is a redox process. You see this one, this picture, it is very clear. Yeah. So first of all, we are taking the two rods here, zinc rod as well as copper rod, normal rods. So you see play above, so above part of the rods, this one and here this one. So here whatever the rods we are taking, so here complete rod is like this, but after chemical reaction it is appearing like this. So first of all, two rods are like this one and this one. After chemical reaction taking place, what is happening? Zinc is dissolving in the zinc sulfate. That means some of the zinc, it is losing electrons. So zinc rod is dissolving in the zinc sulfate solution. So it is losing electron. That's why like this. So disappearing some of the part of the zinc rod. Okay, some of the part of the zinc rod is dissolving in the zinc sulfate solution. Meanwhile, what is happening? The electron flow is like this, and some of the copper is depositing on the copper rod. So extra copper is present here. You see very clear here. So this copper is coming from the like this. Okay. So whatever the electron flow, so from the copper sulfate solution, copper is depositing on the copper rod. Okay, this is a overall reaction. So that's why zinc is undergoing oxidation and copper is undergoing reduction. You see this picture. Okay, I hope it is clear to everyone. See this one. Yeah, next one. Spontaneous reaction of zinc and copper 2 plus. What is happening? I am taking here copper sulfate and zinc. So zinc rod will be converted into zinc 2 plus spontaneously. So here zinc is converting into zinc 2 plus and copper 2 plus is converting to copper. So I am dipping the zinc rod in the copper sulfate solution. That's why this is disappearing. So like this it is happening. If I take the copper sulfate, zinc sulfate and copper rod, if I take here zinc sulfate and copper rod, I am dipping the zinc copper rod in the zinc sulfate. There was no spontaneous reaction. Okay, only the zinc rod is dipping in the copper sulfate solution. Then spontaneously, so I am putting here. Then what is here? Completely dissolving in the copper sulfate solution. Why? Because it is dissolving based on the E cell values. Okay, we have some E cell values. E cell equal to positive, then the reaction is spontaneous reaction, and delta G. So we have some terms are there. E cell values, electromotive force, E cell value based on that one, and delta G value, free energy, Gibbs free energy also is there. Based on that, we will determine whether the reaction is spontaneous or not. If E cell equal to positive, then that reaction is called as, what is that one? Spontaneous reaction. Okay, zinc always reacted with the copper 2 plus ion and forms the zinc 2 plus ion. Here also forming like that. So this is one of the example for the spontaneous reaction in the electrochemistry. Normal flow of water from high yields to low yields, high altitude to low altitude, that is a general example. So this is the specific electrochemistry example. So zinc rod is dipping in the copper sulfate solution means zinc rod dissolving in the copper sulfate solution. Okay, in this case E cell value is positive. I will show you the E cell, how to calculate the E cell value and what is the value of the E cell value for this specific reaction. Okay, I will show. First of all, zinc rod is dissolving in the copper sulfate solution. This picture indicates. Yeah, see this one. Now, cell potential. Okay, right. We will discuss cell potential. What is cell potential? When any metal or any electrode, not only metal, non-metal also. If you take fluorine, chlorine, these are the non-metals. If I take zinc, copper, silver, aurum, all these are the metals. Okay, whatever the electrode, I am saying simply. Electrode may be metal or non-metal, right? So any electrode when dipped in its own ions, okay. For example, I am taking the copper electrode or zinc electrode. So then what we have to do? We have to dip in the concerned. So that means so some corresponding electrolytic solution, right? See this one. So when a metal or non-metal electrode is dipped in a corresponding electrolytic solution, so what will be happen? So either gaining of electron or losing of electron will be takes place between the electrode as well as corresponding electrolytic solution. Okay. So either it lose the electron or gain the electron. If lose the electron, that is process oxidation. If gain the electron, process reduction. So by doing these any one of these two process, what will be happen? Some electrical potential will be developed. Okay, between the electrode. So see this one. So between the electrode and electrolytic solution, some potential will be developed. Okay, whatever the not only zinc. So any electrode, whatever the fluorine, chlorine, copper, whatever the electrode. So between the electrode as well as electrolytic solution, some electricity will be developed. So okay, that is called as some force is developed. That force is called as cell potential. Okay, by gaining electron or losing electron, some potential, some electricity or some potential, that is good. Some potential will be developed. That potential is called as cell potential. Okay, for example, this one, magnesium losing 2 electrons and forming the magnesium plus 2. Okay, some potential will be developed between the magnesium as well as magnesium chloride or magnesium sulfate. Corresponding electrolytic solution you have to take. So what is happening here? Oxidation process is undergoing. Some potential will be developed. That potential is called as oxidation potential. Why? Because this process is undergoing oxidation. That's why this potential is called as oxidation potential. If I take copper sulfate and copper, what is process will be happen? Copper gain 2 electrons and undergoing reduction. That's why the potential, the developed potential is called as reduction potential. Why? Because copper 2 plus 2 electrons gives copper. It is converting into corresponding copper 2 plus 2 copper. So that potential will be is developing while converting into plus 2 to 0. That means reduction process. That's why the potential is called as reduction potential. Okay, yeah. So like this is a cell potential. Cell potential are two types: oxidation potential and reduction potential. If potential is developing while the process is oxidation, that is called as oxidation potential. If the potential is developing while the process is reduction, that potential is called as reduction potential. Yeah, see how to calculate the cell potential. We are saying, yeah, we are dipping the zinc rod in the zinc sulfate solution. So some potential is developing, that is called as oxidation potential. We are saying, but how to calculate the cell potential? Yeah, some methods are there to calculate the cell potential. Okay, fluorine is there, one of the electrode. Chlorine is the one of the electrode. Aurum is the one of the electrode. How to calculate the cell potential of those electrodes? Okay, yeah, calculating the cell potential. Simple method, it involves to calculate each electrode separately, then overall. Yeah, so for that, E cell equal to E cathode minus E anode. This is a mathematical principle. E cell equal to E cathode minus E anode. So how we will get the E cathode value, E anode, I will explain later. Simply E cell calculation equal to E cathode minus E anode. We have to substitute the values E cathode and well as E anode. Then overall cell reaction. Okay, whatever the cell EMF will be calculated by using this equation. For example, here E cell equal to E cathode developed 1.0 volts. Here E anode value developed 0.5 value volts. Here 1.0 volts, here 0.5 volts. Then overall cell EMF equal to E cell equal to 1.0 minus 0.5. Then what is the value? 1.0 minus 0.5 equal to 0.5 volts. That is the cell EMF, cell potential. We can also write like that: E cell equal to E right minus E left. Okay, we have seen zinc copper like this. So this is E right minus this is E left. Have to substitute zinc value as here copper. Oxidation of cell, reduction of cell. We have to substitute those values. Then we will get total E cell value. Okay, we can take E cathode minus E anode or E right minus E left. Okay, these two we can take. Right. So okay, we can calculate the overall cell reaction. Before that, how to determine the individual cell electrodes. Okay, so how to determine the individual electrodes? Zinc is there. So while converting into zinc 2 plus oxidation process, it has some specific electrode potential value, and zinc 2 plus 2 plus 2 electrons gives zinc. What is that one? Reduction process. While undergoing the reduction also some specific reduction potential value. Okay, while converting oxidation some specific oxidation potential, and while converting reduction process also some reduction potential, some specific reduction potential values are there. Okay, now we have to determine the each electrode individual potential value. Okay, we have to determine the individual potential value, then we can calculate the total cell value easily. First of all, we have to calculate the individual, whatever the cathode value as well as anode value. Okay, then we can calculate the total E cell value. See this one. This is the standard hydrogen electrode. So, okay, the standard hydrogen electrode which is used to calculate the cell potential of another electrode. Okay, so this is a some reference electrode. By using this one, so this is standard electrode, reference electrode. By constant this one, we can calculate the another electrode potential. I am taking here. So this is a platinum wire actually. So this is a platinum foil. Okay, small foil is there here. So here we are taking the 1 molar HCl. Okay, we know what is 1 molar. Molarity we have discussed already. So in the solutions chapter, molarity, normality terms will be. So this is the one of the concentration term. 1 molar, 2 molar, 10 molar, we will calculate the molarity. So number of moles present in the 1 liter solution, molarity is there. That is the concentration term. So according to that, we have to choose the 1 molar H plus ion. H plus ion generally we will take from the HCl solution. Okay, H2SO4 HCl, but generally we will take from the HCl solution. That means we have to prepare the 1 molar H plus concentration ions here. Then here, so this setup, whatever this gas, hydrogen gas is pumping through this one. This is cathode. This is platinum wire. This one. Okay, this is platinum foil, FOIL foil. So here. Now, this is a reference electrode. Why we are choosing this is a reference electrode? Actually, the electrode potential of hydrogen electrode is the value is 0.0 volts. That's why to calculate the corresponding another electrode is easily. So that's why we will take the hydrogen electrode as a standard electrode. Okay, yeah. So standard electrode this one, and so you have to observe this the setup. Whatever the zinc electrode here, hydrogen electrode here. So what is happening? We are connected with the salt bridge and this voltmeter like this. So how much energy, so how much potential is developing in this cell reaction means 0.76 volts. Okay, you have to see here. So 0.76 volts is developing electrical energies. Whatever the potential is developing 0.76. So here, while using this equation, E cell equal to E cathode minus E anode. So we can calculate the total value. How much is developed? 0.76 is developed. Here, see this one. So zinc is converting into zinc 2 plus, and 2 H plus are H plus is accepting electron and converting into H2 gas. So what is the overall reaction? So zinc is converting into zinc 2 plus, and 2H plus is converting into, what is that one? Hydrogen gas. Okay, whatever the HCl. So here 1 molar HCl is there. This is converting into H plus gas. Here hydrogen gas is evolving. Okay, yeah. Here zinc is converting into zinc 2 plus. So how much of potential is developing? So here we are measured, that is 0.76 volts of the potential was developed. Okay, that's why. So the oxidation potential of zinc is 0.76 volts. Here the process is undergoing oxidation, that's why the oxidation potential of zinc is 0.76 volts. Okay, this is the value of the zinc electrode. This is fixed, never change. Okay, whatever the zinc, copper, like that. So we are measured by using the hydrogen electrode. Okay, what is the value? If zinc is undergoing oxidation, it is losing 2 electrons, the potential should be developed how much? 0.76 volts. Okay, by using this we can calculate the any electrode also. So this is fixed, whatever the hydrogen electrode, this is a standard hydrogen electrode, it is fixed. And by changing the in the place of zinc, so whatever the copper, fluorine, hydro, whatever the chlorine, hydrogen, like that. So we can calculate all the values. You see this one, all these values. Fluorine, by getting 2 electrons, 2 minus, that means reduction potential value. What is the value? Plus 2.87. We can calculate all these values by using those, whatever the hydrogen electrode, standard hydrogen electrode at that. So see this one. So in this 2H plus 2 electrons gives hydrogen. What is the value? Either oxidation potential or reduction potential of hydrogen electrode is 0 volts. This one 2H plus 2 electrons 0. You have to see in blue color I indicated here. So this is 0 volts. That's why we have undertaken as a reference electrode. Okay, we can use in the place of zinc, we can use nickel or cobalt or iron 2 plus, zinc or water also we can take. So on electrolysis of water, how it will be converted? It will be converted into hydrogen gas as well as hydroxide. How much of potential will be developed? Minus 0.83 volts will be developed. Okay, we can take aluminum also. Aluminum, by gaining 3 electrons, it will be converted into aluminum. So these all are the all reduction potential values. You see this one. Yeah, so this one. So here zinc is undergoing oxidation and this one overall cell reaction. Yeah, how to calculate the E naught cell? We have discussed already. E naught cell equal to E naught, right? E naught is nothing but naught. Here 0 indicates the standard condition. What are the standard conditions? I will explain simply. E cell equal to E right minus E left, or E cathode minus E anode here. Okay, yeah. So here E cathode is 0. See this one. Here 0. That's why what will be happen? E right minus 0 equal to E right. How much potential is developed? See this one. 0.76 volts is developed. Okay. Yeah. So that value is here. See this one. Yeah. So according to IUPAC nomenclature, so some metals are undergoing the oxidation process, some non-metals are undergoing the reduction process. Already we see this one. Some non-metals, fluorine is a non-metal. What is the process is undergoing? It is undergoing reduction, not the oxidation process. Okay. So fluorine absorbing, so 2 electrons, sorry. Yeah. So by gaining the 2 electrons, it is undergoing the reduction process. Here hydrogen peroxide also converting into corresponding water by gaining the electrons. This is also reduction process. Okay, here chlorine you have to take. So chlorine by gaining the 2 electrons, what is converting? Cl minus. This is also all these are, what is this one? Reduction values. Okay, see this one. So these are whatever the metals, zinc, iron 2 plus, these are the, all these are the reduction processes. But zinc maybe undergoes the reduction process and copper maybe undergoes the so zinc maybe undergoes most of the time to the oxidation process and copper undergoes the reduction process, while zinc and copper is connected. If copper is connected to the silver atom, so what will be happen? Copper undergoes the oxidation and silver undergoes the reduction. So that means copper can undergoes oxidation as well as reduction. So if undergoes the oxidation, so some potential will be developed, that is called as oxidation potential. If it is connected to the silver, so what will be happen? It undergoes the oxidation So that potential is called as oxidation potential. That means, see this one. According to the IUPAC convention, so standard electron potential are called as standard electrode potential or standard reduction potential. Okay. So we have two types of potentials are developing. Electrode, what are the potentials? Oxidation potential as well as reduction potential. So what is the standard? So if we have some confusion will become. Okay, what we have to take, either oxidation potential or reduction potential. For that, to avoid that confusion, according to the IUPAC nomenclature, the IUPAC convention, what they have taken, one is the standard one. What is that one? Generally, we will measure in the reduction potential values. Okay, so that's why I choose all these are reduction potential value. F minus F converting into F minus reduction, Cl to Cl minus reduction. All these are. See this one. Iron 2 plus 2 iron. What is the process here? Gaining of the electron. That's why this is a reduction. All these are reduction potential values here. Lithium plus is gaining electron and forming the lithium. Here minus 3.05 volts. What is the process here? Is it oxidation? No. Generally, lithium undergoes the oxidation process. So how much potential will be developed if it undergoes the oxidation potential? So plus 3.05 volts will be electricity. That means what is the current? Whatever the potential will be developed while undergoing the oxidation. Lithium to lithium plus electron plus 3.05 volts will be developed. But here what we are choosing, lithium plus electron reduction potential, how much? Minus 3.05. So simply E oxidation equal to minus E reduction. Convert interconversion between the oxidation potential to reduction potential to oxidation potential. So E oxidation equal to minus E reduction. If we know the lithium reduction potential value, what is the value? Lithium reduction potential value is minus 3.05 volts. Now I want to know the oxidation potential of the lithium. Then what is the value? Minus 3.05 volts. What is the value? Plus 3.05 volts. That's why we can interconversion between the oxidation potential and reduction potential. Okay, yeah, see this one. For example, here zinc is there. So zinc 2 plus 2 electron. If it is undergoing reduction, how much is developing? Minus 0.76 is developed. See this one, we all discussed already about the zinc electrode here. How much is electrode potential is developed here? 0.76 volts is developed. Why? Because here zinc is undergoing oxidation process. That's why what is the value? Plus 0.76 volts. But in the table, what I indicated here table. So see this one. So zinc 2 plus 2 electron. This process is reduction. That's why what is the sign here? Minus. See this one. So minus 0.76 volts. Why? Because here it is a reduction potential value. Actually, we calculated the oxidation potential. At that, how much developed? So potential is developed plus 0.76 volt. Now we are representing in the table is reduction potential. That's why I'm using minus 0.76 volts. So generally, by observing, you can all the metals, most of the metals having the reduction potential negative values. Okay, that's why these are stronger reducing agents. If the reduction potential are having the positive sign, so positive values, those can be act as a oxidizing. Okay, oxidizing agents. Okay, if in a process, see this one, don't confuse with the oxidizing agent and reducing agent. See this one. In this reaction, magnesium undergoing the oxidation process. Okay. Meanwhile, copper undergoing the reduction. So magnesium undergoing oxidation means it is doing the copper 2 plus reduction process. Okay. It is self undergoing the oxidation means it is reducing the some other species. That's why this whatever the magnesium is called as reducing agent. Okay. While copper is undergoing the reduction, that means it is doing something species. Okay. It is doing the magnesium to undergoes the oxidation. That's why copper 2 plus can act as a oxidizing agent. Okay, don't confuse. Magnesium self undergoing the oxidation. That's why it can reduce the other species. Okay, it can reduce the copper 2 plus. That's why magnesium can act as a reducing agent and copper 2 plus can act as a oxidizing agent, like that. Okay, see this one. Yeah, so fluorine is having the highest E naught reduction potential values plus 2.87 volts. So more positive value, E naught reduction potential, E potential value, reduction potential value is more, those can act as a oxidizing agent. That means if E naught values is negative, okay, then so those can act as a reducing agent. So lithium is in entire periodic table, lithium can act as a strong reducing agent. Why? Because based on this reduction potential value, least reduction potential value having the lithium ion, that's why it can act as a strong reducing agent. Okay, what is the value? Minus 3.05 volts, least reduction potential value. That's why lithium can act as a strong reducing agent in the entire periodic table. Similarly, see this table. So fluorine having the how much? Plus 2.87 highest reduction potential value. So what will be happen? That's why fluorine can act as a strong oxidizing agent. Okay, is it clear? Yeah, I hope it is clear to everyone, right? Yeah, see this one. So in this, two electrodes are we are taking. Okay, zinc sulfate as well as zinc electrode, copper sulfate and copper electrode. So this is anode, this is cathode. So how much potential is developing? 1.10 volts is developing. So how to calculate this one? So actual cell reaction is this one. So this cell reaction is zinc is undergoing zinc 2 plus and copper 2 plus to copper. This is the overall cell reaction. Oxidation of cell means zinc 2 plus reduction of cell to copper 2 plus 2 electrons gives copper. That is reduction half cell. So total EMF of the cell, E cell equal to E right minus E left, this one. Okay, yeah. So how to calculate E cell equal to E right minus E left? So what is the value of E right? That means zinc electrode. So this one, right? Sorry, not right. We have to take right. Cathode, E cathode minus E anode, or E right minus E left. Right. So here in this right cell, we are taking the copper sulfate, so electrolytic solution, and copper rod. Okay, this one. So how much is developing potential? By calculating the standard hydrogen electrode, their reduction potential value, E cathode value developed is 0.34 volts. This is a fixed value. While copper is undergoing the reduction, this is fixed value 0.34 volts. So this is E cathode value or E right. So why? Because we have taken the right side, that's why E right. So E cathode minus E anode or E right minus E left. What is the value of E right? 0.34 volts. Next, negative. What is the E left value? E left value, and this means zinc sulfate solution. How much is developing? Minus 0.76 volts. Okay, right. E right minus E left. So minus into minus, what will be happen? Plus. Okay, 0.34 volts plus minus into minus plus 0.76 volts. By adding these two, what will be happen? 1.10 volts will be total cell EMF. Okay, cell EMF how much? Complete cell EMF, total EMF cell is 1.10 volts. E right minus E left or E cathode minus E anode. So this is the value of this cell. Okay, I hope it is clear. Yeah, you have to take simply E right minus E left. So if you have some confusion, simply you have to take, if two reduction potential are given, so while calculating the cell EMF, you have to take the highest reduction potential minus reduction potential minus lower reduction potential value. Here he will mention the value simply. So E naught cell of copper 2 plus 2 copper, okay, will give 0.34 volts. Okay, reduction potential values of A, B, both he will give. Simply you have to subtract the higher reduction potential value minus lower reduction potential value. Here higher is 0.34 volt. Here negative charge is there. That's why this is lower value. Here positive charge is there. So higher value minus lower value. But specific when both are should be in the reduction potential value. It is not applicable if the values are oxidation process. In mostly you will not give the oxidation process. Generally you will give, the examiner also gives the reduction potential value. Why? Because it is the authentic. This is the standard value according to the IUPAC. Both the values are present, oxidation values as well as reduction potential values. But we have to take reduction potential value as a standard value. Now we have to calculate the standard E naught value here. Not 0 indicates the standard condition. Okay, with any condition, if I take here zinc sulfate, if I take 2 molar 3 molar like that, if I take the different atmospheric, if it is solution, that means if it is liquid, zinc sulfate is a liquid, what I am saying, that's why 1 molar solution. So I can do this reaction with the different concentration also, that means 2.5 molar, 10 molar like that. So two different types of concentration solution, different electricity will be, the potential will be developed. So what is standard EMF? E naught cell standard means, so if it is solution, we have to take the 1 molar concentration solution. If it is gas, if I take chlorine, Cl2 is a gas. Okay, hydrogen is a gas. For that gases, what we have to choose? 1 atmosphere pressure. If it is a solution, we have to take 1 molar, and if it is a gas, we have to take 1 atmospheric pressure. And what is the temperature? 298 Kelvin. So it is a room temperature, 25 degrees centigrades, or it will be converted into 298 kelvins. Okay, yeah, we have to take the 298 Kelvin temperature and 1 mole 1 molar concentration solution. This is for the solutions and this is for the gases. So E same, we followed E right minus E left, or E cathode minus E anode. Similar here also we have to follow E naught cell standard potential of a cell equal to E cathode minus E anode. Here E naught indicates the simple standard condition, that is 298 Kelvin temperature and as well as 1 molar concentration. So that is standard conditions. Yeah. So E naught value. So what is this one? What E naught more